Hello, everyone. My name is Ahmed. I'm a software engineer. I'm an Apache Beam committer as well, and I have been working with Beam connectors for some time now. And today, I'd like to talk to you guys about managed IOs and what they are, and how they work, and what kind of problems that they are intended for. So here's our agenda. First, we'll look at what Beam pipelines look like today and what it means to upgrade a Beam SDK version to a newer version. We'll talk about how we can leverage managed IOs to upgrade specific transforms instead of the whole pipeline. And we'll dive a little bit into how this transform upgrading works. We'll talk about how the runner can come in and tweak the configuration a little bit to optimize it based on the runner's options. And we'll finally have a short Dataflow runner demo. So this is an example of a normal Beam pipeline. You have some connectors, you have some custom transforms. You're calling the connectors with their direct API. Your dependencies all have the same Beam version, and you end up with this pipeline that has one specific version throughout. Whether it's a custom transform or an IO, everything is the same. Now, let's say a new SDK version comes about and it has some exciting features, some bug fixes, performance improvements. It fixes some security vulnerabilities. Maybe there's other incentives as well. And you want to upgrade, but then at the same time, whenever you upgrade, you always have this maintenance overhead. You notice that sometimes you upgrade and it pulls in some transitive dependencies that are incompatible with your project. So you have to always sift through disentangle, the dependency issues that you have to find the root cause. In some cases, also, you might see that you get all these exciting improvements in some IOs, but then one IO that you're using ends up having a regression in the new SDK. And all of these issues are not unique to Beam. These are just natural issues with upgrading libraries in general. But we've seen a lot of users not wanting to upgrade to newer versions because of these reasons. So that's why managed IOs came about. And these are IOs that Beam can inspect and take their configuration, convert it into bytes, and store those bytes onto the pipeline photograph. And what this does is it allows the service or the runner that is executing the pipeline to extract these bytes and convert it back to a configuration and rebuild the transform. And we'll get into it a little bit more, into a little bit more details. But first, we'll talk a little bit more about managed IOs. So like I said, these are IOs that can provide this logic that translates between the bytes and the configuration. One added benefit too is it has a unified interface between different IOs and between Java and Python. So all you need to do is to just use this unified API for all managed IOs and just specify the type of IO that you're trying to use. And all of the configuration can be put in as a map, as you can see here. And this is consistent between Java and Python. And we also try to keep the configuration options consistent across IOs. And so if you look at this page over here, you will see a centralized place for all the configurations that you can use for each IO, and some descriptions and typing and so on. And as I mentioned, all of these are consistent for both Java and Python. Okay, so now we'll get into how the logic for upgrading works. So let's take a look at the original pipeline that I showed in the beginning, but let's replace this IcebergIO sync with its managed version. Now, what happens is you provide a configuration to, configure the transform. So Beam will build the transform based on your configuration, but then it takes an extra step because this is a managed I/O, and it will serialize the configuration into bytes and attach that configuration onto the actual I/O, onto the photo graph. And then the runner can then come along and it can see the I/O and it can see the configuration bytes here. It takes it and it deserializes the configuration. And then it takes the configuration to its own backend. And it has access to a upgraded service. This is, like a service that just stays up to date with the newest stable version of Beam. And it then uses this configuration to build the same I/O in a newer version. And then it takes this I/O, replaces it, and you end up with something that looks like this. You still have the same pipeline version that you started off with. Your dependencies look the same. You did not need to upgrade anything, but the runner itself injected these newer IOs into your pipeline without you having to do anything on your end. And one thing that also changed is your API. Instead of calling the IOs directly, you're calling them through the managed interface that is unified, and it's easy to just replace, replace this with Iceberg or this with BigQuery, because the API is very similar, so it's easy to be interchangeable. So one other benefit is that the runner itself can come in and modify the transform configuration. So as an example, this is a real example that currently works, is the managed BigQueryIO sync with the Dataflow runner. So here we have a normal configuration for BigQueryIO. The Dataflow runner will come along and it will check and see if this Dataflow option is set. And just briefly, this option just tells Dataflow that the user is okay with duplicates. Dataflow has a bunch of, logic and, like complexity in place to make sure that everything is being processed exactly once. But this tells Dataflow to relax and, like be more cost efficient because the user is okay with duplicates. So when Dataflow notices this, it sets this option in the BigQuery configuration, which uses the BigQuery at least once mode, which is also cost efficient and all that stuff, but just comes at the risk of data duplication. But since you're okay with that already, then, you might as well use this optimization. So this is an example of the runner changing the configuration of the IO, rebuilding it, and then replacing your old IO with it. So a special call out for Dataflow Runner V2, this runner will do everything I just said automatically. So it goes through your pipeline and it detects all the managed IOs and attempts to upgrade all of them first before executing. And then the same thing happens when you're running a streaming pipeline. Let's say you have a pipeline that's been running for some months now, and it's been running long enough so that like 2 or 3 new Beam releases have come out. When you come back to your pipeline and hit update, the pipeline will first attempt to fetch the latest stable Beam version and rebuild your IOs and then inject them into your pipeline again. So you're updating, but you're also refreshing your IOs to use the newest version. So now let's hop onto this small demo that uses the Dataflow runner to showcase how everything I just said works. So let's get into it. Okay, so here we have a simple pipeline. It just calls the managed API to read from Iceberg, and it's telling it to read from this specific table. And with these catalog properties, this is a Hadoop table that is in a GCS warehouse. And I'm going to print the elements just to show you what is inside this table. So here it is. We have a bunch of rows that have 3 columns each, ID, name, and bool. And I'm running this on on Beam 2.59. Now this is a version that does not have support for creating tables in Iceberg. That feature came in 2.61. So now if I try to use this old version to take my input and write it to a new table, I will see an error. And this pipeline basically just capitalizes the name field, does a count and reformats into rows again, and then writes it to the new table. So this table does not exist yet, and we'll attempt to write to it, and we should expect an error because we don't have the support for creating tables in this old version. But then let's say I enable the Dataflow runner and send it there. We'll find that Dataflow will receive this pipeline graph, and it will identify that we have a managed IO, and it will upgrade that IO. And it will upgrade it to a newer version that does have this feature, creating tables. And hopefully the pipeline will work. So let's take a look at our pipeline. So as you can see, this didn't change. We're still using the older version 2.59, but now what the runner is doing is it has received these 2 transforms, Iceberg read and Iceberg write, and it's currently it's being processed by Dataflow, which means it's trying to fetch the newer versions of these 2 transforms. So it will take some time to do that, and then we'll get back when the pipeline starts running. Okay, so we're back, and we can see that the pipeline started, and it has successfully found those 2 transforms and upgraded them. And now we'll wait for the workers to start up. So as we can see, the pipeline succeeded, and let's look at what happened in these worker logs. So locally, the pipeline failed because it couldn't create create the table. But here we can see that the pipeline that is running on the newer version of the IcebergIO was able to, use this feature because it exists in the newer version. The newer version supports creating the Iceberg table. So it was able to create it and successfully write to it, and everyone's happy. And as the user, I didn't have to change my dependencies or have to, deal with any of that. Dataflow was able to, as you can see back here, Dataflow was able to intercept these managed IOs and upgrade them and use the newer versions. So that's the main benefit of managed IO. That's it for this talk. Thank you very much for your time and your attention. Here are some contacts that you can contact me at if you have any questions or suggestions or anything like that. And feel free to ask me questions here too. Thank you very much for listening.